Recording in
All right, so I think the audio is on. So audio is on. All right, so it looks like it's on and it is recording. So let me then share the screen. All right, so we are now recording, and I'll post, if everything records well, I'll post this video on YouTube. I just have to make sure that audio works. All right, anyway, so we're starting here, right? So as I said, we're gonna look at NumPy. I've called the script Torch and NumPy. We're kind of going to play with that. We're gonna add a couple of libraries here. So import Torch. I'm also going to import, obviously, NumPy this time. I'm sorry. In the video, it'll show. Right, so anyway, yeah, thank you. A lot of technology. All right, so import Torch, import NumPy. Now there's a convention that you always do this, as NP. You can do that for Torch as well. Those are just preferences that you're going to have to develop. Okay, we're also going to import a new library today, which is H5PY. Right, this library actually, it's going to become part of what you do, because a lot of the time you're going to train a model, right? You're going to train the model, and then you're going to be done with it for a day or a couple of days, and then you say, okay, you know what? I'm going to save this model, and then later on I'm going to use this model again, so I don't have to train it again, right? And so that's very handy and very easy to do, convenient in both TensorFlow and Torch. You just basically save the models to this extension using that library, and then you have your little model with you that you can take and use it later on for various applications. So we'll see examples today of using this library just to start saving some files, some data. Eventually, we're going to start saving all the models, etc. Okay. I'm going to also add this print statement that I like to add, just so I can always make sure that my code is not, in a loop or something. Done. And remember, with all of this, even though I'm not really assigning homework right now, because in the first few weeks, we just have to build up a lot of little things, a lot of primitives and skills, make sure you're practicing all of these, okay? You should really try to learn it in such a way that you kind of just memorize it, all right? So practice all of these at home, and then eventually, once we're done, we're ready for something, we're gonna tackle a specific problem, okay? So right now we're just learning some of the elements through the code. And, as I said, later on, I'll start to explain a lot more things. So we have the libraries now. So let's go ahead and we talked about transposition the last time we met, and the transpose is actually a complex thing, broadcasting, the transpose. Those are things that, although they are difficult, I like to introduce them really quickly. Eventually, as you start to need them, you're going to use them and get practice. The only way to really get it is to practice, okay? So don't worry so much about it right now. So anyway, so this section now, I'm going to call Numpy Interoperability. Okay, and the idea is that, as I explained, go from a Torch tensor to a NumPy tensor back and forth. And that's going to be very convenient. So how do we do that? So let's go ahead and create a tensor. So I'm going to say points dot torch. Oh, sorry, not points equal torch dot ones. And this is something we saw last week. So basically, I'm creating a tensor of size 3 by 4. So this would possibly be 3 samples with 4 columns each. Okay, so 3 vectors of dimensionality 4, that kind of thing. All right, a lot of what we do with TensorFlow or PyTorch is revolves around these tensors and the dimensions. So now that I have points as a tensor, I can go ahead and just convert it to a NumPy array. Okay, I'm going to convert it to a NumPy array. So I'm just going to say points underscore NP for NumPy, right? And it's pretty easy. It's like extremely easy. So you say points dot NumPy like that. And believe it or not, this one statement is incredibly useful. All right, it's one thing because you always want to look at your data. You always want to get a feel for your data. And NumPy is very easy to operate on. So now that I have NumPy, then I can go ahead and just do something like print. And I'm going to print points underscore NP. So let's go ahead and save this one. All right, Control X, Y, right? In Nano, you can use any editor that you prefer. All right, and now we're going to do Python torch to NumPy. All right, and we are waiting for this to come up. Okay, so no module H5PY. So what we have to do then is what? We have to install it. Because we're in the conda environment, we're going to do conda install H5PY. That's a very common thing that we're going to use all the time. As I said, nowadays with Docker and everything, you can spin up pretty much the thing that you need. Kind of build them, destroy them, whatever you want. But here, let's take this approach. So I'm going to install the library. Okay. All right, so hit yes. All right, so it seems like it did it. So I'm going to do a clear, run it again, and there it is. As you can see, it is 3x4. It is a NumPy array of all ones. Okay, that's all we've done. So today, all we've done is really create this NumPy array. All right, now that I have it, so what else can we do with a NumPy array? So we have, what about converting it back to Torch, right? So that's something that we're definitely going to need if we are going to do a model. So this is a common example of taking data from a text file, from a CSV file, reading it as with some library as NumPy, and then from NumPy, make sure you get the dimensions correct, and you just feed it into a tensor, a torch tensor. That is to say, a tensor, but in the data structure of Torch, right? And then feed it into the Torch model. So let's go ahead and do that now. So I'm going to say points, right? And then just add a little like T here for Torch underscore T. And we're going to convert this so Torch dot from NumPy, right? And what, and we're going to take in as input points N. Okay, so points underscore or NP, sorry, for NumPy. And that's it. So we do that, and that should give us our tensor, our Torch tensor. So let's go ahead and print that one. So I always like to print things out just to get a feel for what's going on. And I recommend you guys should also do that, right? As you're playing around with your code. So let's do Control X, Y. All right, I'm going to run it again. You guys see that? Do you see the difference? One is NumPy, the other one says tensor. It's a Torch tensor, right? In the two libraries. Now let's take a look at saving a tensor. So that's, in TensorFlow, you can save a lot or anything, right? These things are usually called snapshots eventually. And what a snapshot is basically a snapshot of the model, for instance. So as you're training the model, think about the real big problems, right? We're talking about a thing that you run over a week of training, something like that, right? So you want to save snapshots of the model itself. So you're going to start saving it to these files, right? And just save it on your computer so that you can always revert back to a snapshot, etc. And so in case the machine dies, right? So that can happen, right? Your computer dies for whatever reason, but you have a snapshot of it, so you can just start from there. But, you know, before we do all that and save to files, let's just look at the very basic things. So this is sometimes called serializing, and it's just converting the file into, you know, some kind of a binary file that is can very efficiently be read into Torch itself. So let's start with a simple example. Let's just save. So if we go back to the code, let's just save points, right? So let's create a new line here. So I'm going to add a new comment line. And we're going to say here that we want, let's give this a comment. So for instance, I'm going to say saving to file. Okay. So in this case, I'm going to take, there's many ways of doing this. It's just one way. So I'm just going to say, you know, torch save. Notice I have these bad habits, like I make the parentheses really big. You don't have to do that. It's not required for the syntax. But if you see me, I have these quirky things. All right. So anyway, so I have torch.save here, right? And I'm going to take what? As input, I'm going to take some variable. In this case, we can take points, for instance, right? So we can take the original torch one. So it's going to be this one over here. Points, which is a torch element, given that we're using torch, makes sense, right? We're using the appropriate library. So now I'm going to say points, right? That's the file, and then I just specify how I want to, where I want to save it. So I'm probably, you know, because I don't want to, you know, we're going to start using a lot of data files soon. So I don't want to create a mess in this folder. So I'm definitely going to need to create a folder, a subfolder here called data. All right, you have to manually create that one. So this has to be commented. Okay, so this has to be commented here. So it's going to be data, and then we're going to give it a name. So I'm going to call it examples, or what is it? Example points. Let's see. Example points dot t. The extension doesn't really matter, but just, you know, dot t, for instance, for Tensor. So that should save it. So let's try that one. Remember, for this to work, you have to create a folder. So mk directory data. All right, that should have created your folder in here. So if I do ls-l, you can see the little flag says D for folder, data folder. All right, so I'm going to save it. If I currently go into data, there should be nothing, of course. That's empty. Let's see. And so we're going to go back. All right, and now run our Torch NumPy script. All right, and as you can see, we should have created the file, right? So I'm going to go into data now. And you can see there's my file. We can check the parameters of it. You can see size is 389. And so that's basically the saving a file, right? So these things are very useful, as I said, much more so later on. But today's theme, honestly, it's a lot about data, all right? So we're going to be reading in data. We're going to be, you know, doing these kinds of things. So, well, if we wrote data out, now let's read it in, right? So that's something else you might want to do. So we're going to create or call up our script. Oh, we need to get out of here. So let's do cd ... All right, and then let's open up Torch. All right, so we're going to scroll all the way down. All right, so on that same note, we're going to create now a new variable. Let's call it points2, right? So points2 to kind of show that we can read from that file that we just created. So we do something similar. We're going to say torch.load, okay? And then we need to specify what we're reading from. All right, so in this case, it's going to be data example points .t, I think we call it. Example points .t. So, and then of course, it's going to be a torch tensor once again, similar to the original one. So we can just do print, and then we're going to print out points. Oops, sorry. Points to, right? Oops, just like that. All right, so we're going to print out this tensor and just take a look, and it should be the same one. So if I run the code again, you can see there it is again. It looks exactly like the original one, but now you start to develop some skills to save information. Now let's combine a lot of the things that we learned, NumPy and saving a file, and let's create an HDF5 file, right? So that means, remember, these are the files that are going to become useful later on to save models, etc. So let's play with this file right now. Or this library, sorry. So this is, let's go back to our code, of course. And so I'm going to scroll down here. All right. So I'm going to scroll down here. And I'm going to call this, let's say serializing, because you really think of it as like a binary representation of your model, because it has to be read efficiently. Remember that everything has to be read efficiently for Torch to be fast, right? And the GPU, etc. So a lot of it is binary or C code, compiled code. So let's do serializing with so a lot of so let's see. So we're going to do serializing with HDF5. Okay. All right. So let's create, first of all, the file itself. And what we want to do, so this is very much like Python, it's a similar idea. We're going to call in the library is actually called H5py. Yeah, so H5py. Dot. And then we're going to say file. So we're going to define the file that we want. Notice the uppercase F here. So notice that. And then again, we can specify the file name. So this should be pretty easy to define. So again, we're going to save our data in, or sorry, our files in the data folder. So I'm going to say data / and now we're going to call it points.hdf5. Okay. And we also want to specify that we want to write to it. So we're going to specify a W for writing. Okay. So that's the definition, the declaration of the object for files. Now let's create a data set. Now keep in mind that a lot of things, when we're dealing with data, we're dealing with data sets. So we're going to have a lot of the time some built-in modules like create data set, etc. So I'm going to do dset, just some name, and I'm going to say f dot create. So create underscore data set. Okay. And so now these data sets can actually have several objects, right? There could be like targets, the labels, there could be the data itself, so you can label these things. So in this case, we're going to call this one just coordinates so that we can later on, this is like a subset of things, of objects, and when we can grab each individual object. So here we say coordinates, comma, and then the data itself, right? And it's going to come from somewhere. So notice that, unfortunately, we have a problem. We have point is a tensor torch, but this takes a NumPy array. So what do we do? We just saw it, right? We take points and then dot to NumPy, right? And there you go. See how handy that is? Solved it, right? So that's the point that, it makes it very useful And it wasn't always like this, believe me, it was a little bit more painful. All right, and so now we have, you know, points, spelling looks correct. Take just the original points. NumPy basically here. And of course, we close this object. So we're going to say f.close. All right, and now we've closed the file and we can proceed to see if it gets created basically. So I'm going to do Control X, Y. All right, then we run it. All right, so we need to go into the data folder. We clear here. All right, and there you can see that we have, in fact, notice that the HD5 or HDF5 is much bigger. Even though it's the same original points tensor, if you will, it's a lot bigger, and that's just because it's got overhead in there, or because it's a data set. So it's a very powerful library, very useful for saving things later on. Everyone good so far? Making sense? As I said, today is actually pretty interesting because we're going to deal with data, more data sets, you know, how to deal with the tensors. Later on, as we move into the semester, we're going to actually, you're going to get raw data and then feed it into these tensors and then feed that into the models. That's the whole pipeline right there, right? From raw data to process data, to playing with the tensors, to building the models and so on. All right, and so anyway, that is writing the file. So now, of course, you might wonder, okay, so what if I need to read the file? So then we're going to go back to Torch. Oops, am I in the wrong place? Okay. Oh, that's right. Yeah, so I'm in the wrong folder. Check data. So I need to do cd dot. Okay, so there is my file. So now I'm going to do this. Okay. And I'm going to scroll all the way down. So now the next question is, how do I read that file back where I need it to be? And I need it to be a tensor. Okay, so this is a classic problem. So let's see. So I'm going to define the object just like I did before. So h5py dot file, open parentheses, close parentheses, data, and then, you know, the name is points dot hd or df5, like that. And instead of writing, though, this time we are going to read. So, you know, we use the R flag there pretty simply. And then now that this object pretty much takes care of getting the file. So now we can say, I want to read the set 1, let's say, 2. And that's just going to be F. And then we just need to specify the name that we gave it when we added it to the data set, which was called coordinates, right? So chords. I'm going to do chords here, like that. That's it. So now I have it. And now let's say that I want to load the data again. So I'm going to do print. This should be a Numpy array. So I'm going to say dset. All right, let's go ahead and run that one. All right, so that's a closed HD5 data set. So now let's take a look. Let's convert it into a tensor. So I'm going to say, let's go back to nano here. Oh, I'm sorry. This should have been D1. Sorry about that. All right, so Control X, Y. There you go. So that's the shape of it, 3x4 towards data set 3x4. Okay, so now let's go back. And let's convert it back into a tensor. So I'm gonna do points final, let's say, points final, torch dot from numpy, and it should be actually, I'm gonna, just to be consistent, final underscore t for tensor, and this should be d set 1. And also, I don't want to forget to close the file, so I'm just going to throw that in there. F.close. All right. So now I'm going to proceed. Oh, and I need to have one final print. So this is going to be print points. Call this points. Points final underscore t. So let's go ahead on that one. Oh, okay. Expected NPD array. Okay. Oh, I got it. Hold on. So let's do. So here, this is technically a data set. So what I need is here, D set 1 is going to be D set 1. Should be that. Okay. There you go. So what was happening is you kind of grab the data set itself, like the data structure. You kind of have to slice it out of there, okay, with HD5. And if you notice, that's kind of what I did. So by doing that, I was able to actually get the data back out. And as I said, these things, don't worry about it if you're like, oh my God, how did you know that? You know, these are kind of things that it takes practice to pick up. That's all it is. All right. So you'll pick up the practice. That's why you need to have the source code as, you know, to look at. But anyway, you saw what I did. You know, you can also remember slice other things, right? Like saying, you know, just not the whole thing, but part of it, right? So you can slice out just certain columns or certain rows, etc., and play with it. All right, and that's basically it. At that point, we took the data set and we converted it to NumPy. Therefore, here, you know, this is a NumPy array, and we can kind of confirm that because it, you know, when we look at it, see it, you know, oh, actually, no, we made it into Torch, right? So we did that last statement where we converted it into Torch. So in this statement here, Torch from NumPy actually converted it to Torch. And that's why it says tensor something, something. Does this make sense? Guys? If you wanted it to NumPy, again, you do what we did over here, points.numpy, back and forth. This is really important, actually. I think it's simple enough, but very, very, very useful. Okay, always very useful to be able to convert something, because you might find a library, especially for image processing, things like that, where it only handles NumPy kind of by default. So then, play with that. All right, so are there any questions? This completes sort of the playing around with NumPy to Tensor and some of the read and writes. All right, if there are no questions, then we're going to move on to another script, okay, another set of scripts over here. So I'm going to go ahead and save. I'm just going to confirm that the volume is working. I think, hope it is. With my computer, this is iffy always. Okay. Test. All right. So hopefully it's working. All right, so now let's proceed, and we are going to just create a new script. Now we're going to start getting into more fun things. Okay, so I think these kind of mechanics are very useful, of course, but they may not be as fun as what you would like to do with Torch or with machine learning in general. So let's go ahead. So we did. Just want to make sure I finish this. Yeah. All right. So now, if you're following with my GitHub, right, we've completed basically the basics with Torch PY script. We're done with that one. So now let's move on to read data to PyTorch. All right. So to read data to PyTorch, we definitely are going to need the data.zip file. So I'm going to have to open here in the computer, the web browser. All right. And this is the web browser. So let me just go to my website where I have these courses. Oops, right there. Okay. What did I do? Did I disconnect? Accident. Oh. Yeah, I think I disconnected. Sorry, guys. Give me a sec. All right, so we should be back, I believe. Yeah, this looks like our environment. So we need to download. So let's go to, right, so let's go to code, right? In code, under PyTorch, you can get, under basics, right? I already posted the data.zip file. All right, so you just get this data file. It'll have all the files that you need for today's class. And we're just going to play with reading some data in. So I'm going to go ahead and probably need to download the whole thing. Huh? So let me go back one level. All right, and I'm going to download the zip. So make sure you do this, okay? Download the zip. All right, so that hopefully did it. All right, so now let's go to downloads in the file system. There should be a downloads in here. Or not. There it is, downloads. All right, so which one is it? There it is, PyTorch main. Extract here. PyTorch main. And then basics. And then it is this one. All right, and then you can just go to data. And there are the files. So you guys can see this, right? You know how to get them. All right, so the files in question are, the kinds of things that you would expect, when you're doing machine learning, right? So some images, some text, and a CSV. CSV is what? Comma separated, right? And usually you have the rows are the samples, the columns are the things. So here we have an example of wine quality. Okay. We also have, a picture, .jpeg, Bobby. I think it's a dog. Then we have pictures of cats. Obviously, I only have like 3 because it gets really large. But obviously, you can have however many you want it. 3 is enough to treat it as a batch. And then we also have some text over here. So if you take a look at this, this is I usually like to use things from the Project Gutenberg, the Gutenberg.com or .org, I think it is, website. And this is Pride and Prejudice from Jane Austen. Okay, so we grab some text and we're gonna, we can play with it. So I'll show you guys some of the functionality. Now this, guys, is what you will be doing. Your term project will involve most likely one of these 3 files, 3 type of files. It'll either be text, right? It could be Twitter data, it could be tweets. Think about companies and what they do, right? So they're, if you're a company that wants to sell aggregated information, or if you're a company that wants to sell ads, whatever it is, right? You're going to have to process this kind of information, right? You might have a lot of data stored in databases. That's usually called structured data, or you might have a lot of data like this, which is referred to as unstructured data, like natural language text, right? So, and that usually falls under an area called natural language processing. But this is not an NLP class, so we're not going to get into a lot of those tools. But I'm just saying for the term project, you guys will certainly be using one of these 2 types. So pay attention to this one. All right, so what are we going to do? So the first thing, so I showed you there's a text here. There's a lot of text, right? Basically a book. So how do I close this? Yeah. So what I'm going to do is I want the cats, and I want the Jane Austen, Bobby. These are just the files that I just showed you how to generate. And then, of course, the CSV. A lot of the time, CSV would be something like if you have data in databases, right? And you all know about SQL, right? SQL queries. And so you're going to make a SQL query, get your data, and maybe it looks like a CSV, all right? So that's the idea. So now I'm going to go ahead and just try to copy these. Okay. And of course, I'm working on the desktop, full 2021, and under data over here, I'm just going to plug in those. All right, there they are. And so this will make our processing pretty straightforward. So now we're going to go ahead and we're going to try to create a new script. So so you guys know where it is, right? So this is in data. We've downloaded the files. You saw where I got them from. So now let's go ahead. Let's go back to our terminal. And we can confirm by going into data over here. All right. LS. And you can see the files are there. All the files have been copied. So let's exit out of here. All right. And now I'm just going to create a new script, to keep these simple. And this one, as you might imagine, is called read data to PyTorch. Right? Any name that you want. So read data to PyTorch.py. You now, in theory, know what tensors are, right? You know about slicing. You know about how to manipulate interoperability between Numpy and Torch in our particular case. So now that ability should be waiting, right? And now what you need is the part of the pipeline that grabs the data as raw data and loads it into those tensors, whether to a Numpy array first, and then a Torch tensor, or but the goal is for them to become tensors, right? So that's kind of what we're going to explore. So I'm going to open up the script over here. All right. We're going to add, just like, maybe let's add a comment. Let's just say read data to PyTorch. Read data to PyTorch. And then we're going to do import torch, of course, because that's, what we're studying. What else? NumPy, probably, right? So import NumPy as NP. Import OS. That's just a standard Python library, because we're going to be reading data from the file system. So we probably want to use the OS to kind of read the data efficiently. And finally, we're going to install a library, a new one, because we're going to be processing one. We're going to be processing images. And therefore, and there are many, by the way, there are many libraries for image processing. Okay, so this is, or for reading an image at least. So this is just one of them. All right, so this is image.io is the name of the library. Obviously, that's not going to be installed yet, but because we're using Conda, that's not really an issue for us. We're just going to install it in our version that we're using in our environment. So I'm just going to add my own print, as I usually do. So I'm adding this one. All right, so let's save it here. So Control X, Y. If we run this, it's going to give us the error of where is this library, right? So it's going to say that. So let's try it out. Let's do Python, right? No module image.io, right? So pretty common thing. So what do? Conda. Install. So Conda install image.io. Let's go ahead and try to install that one. Hit yes. All right, and it finished. So we do a clear. If I run this again, you can see it ran perfectly. So now I have image.io. So let's get to it, right? So let's read in one image. We're going to read in Bobby. Okay, so let's open up our script. So I'm going to do. Now, keep in mind that a lot of machine learning was developed initially around images. There's a lot around that field. And so some of the problems that we will do this semester have to do with image processing. Okay, so but it's going to be good little exercises to just do. Okay, but today my goal is for us to look at 3 different types of data sources. Okay, keep in mind whenever let's say that I give you an assignment, go get some as much Twitter data as you can and tell me something about it. You're usually just going to download the tweets and save them to a text file, very much like the Jane Austen thing that you saw, right? And then a tweet can be treated as a sentence, if you will. So that can be the same idea. So anyway, let's read in the picture first. So I'm going to do img and underscore, let's say R for array, and I'm going to call the library image.io, right? And I'm going to say im read. Okay, so I'm going to read in the image that I want, and the image that I want is going to be from data Bobby. So Bobby.jpg. Notice extensions are important. Okay, every extension type, whether it's JPEG or PNG or anything like that, will always have different formats. Sometimes, for instance, they're RGB, but depending on the type, they might have a transparency, or for the watermark, so they actually end up having the 3 channels of RGB plus a couple more. So the data structure itself may not be of 3, but 5 or something like that. So we have to play with all of that and be aware. So let's test this one out. So we read it, IM read, and now let's try to print it out. Let's just see what happens, right? So I'm going to do img r for array and then dot shape. So remember, remember what I said. Using shapes usually becomes the thing to do because these arrays become really big really quickly. This is an actual image. We're going to know the dimensions in a second, but it could be pretty big to visualize, etc. Visualize the data. So let's go ahead and run this one. So I'm going to do Control X, Y. Do Python here. All right. And there you go. So what can you guys tell me about that image? What do you think? It's color image, right? And it is 976 by 1334. Do you think that's a big size for machine learning purposes? Or do you think it's small? Or that you have to think like this, okay? You have to think about the limits of machine learning from now on, right? And so whenever I see something like this, I immediately start thinking, is this too big? And that is probably too big. Because yeah, 1 is not a big deal, but if you have 100,000 images, for machine learning, and you're going to give it batches of 64 images at a time, and then you have to in a neural network with millions of parameters, it's going to run out of memory. Okay, so this is big. I think images that are 300 by 300 are about as big as you should go. So you downsample and modify. Okay, be aware of that. Okay, but so this is a big one, but for our purposes is important. Another a very important thing is that images usually look like this. So it's like what is it? The height, the width, and the channel. That's usually what you get from the image originally. PyTorch does not use that order. PyTorch by default requires images in an order of channel, height, width. Okay, always. That's just a PyTorch thing, probably to make it more consistent, reduce errors, and it kind of makes sense. Okay, so just be aware of that. You're always having to play with the shapes, etc. But we'll do that. Just be aware. So now we just printed the size of this. Now let's remember that to feed this into PyTorch, we have to change the order. So let's go ahead and do that. And then we're just gonna, as I said, today we're kind of playing with data, reading it and knowing how to process. So let's add a comment here. Let's say PyTorch requires images in the form where this is going to be channel, the RGB, by height, by width. Oops. Okay. So that's what tensors are, right? So these are tensors. That's where the tensor comes in, because think about that. That's a cube, right? Channel by height by width, and it's only 1. But when we do training, we're going to want to feed 64 images at a time, right? So that is going to be a hypercube of 4 dimensions, where the first one will be the batch, second one is the channel, and third and fourth are height and width. Does that make sense? Okay, so that's pretty important. So really quickly here, when we talk about images, tensors become very real. Okay, they become very real in the sense that we're in 4 dimensions now with the data. Imagine now if you're doing CT scans, right? Or something like that, you know, it's even bigger, volumetric stuff. So dimensions are pretty important, but again, the other way of thinking about that is that these libraries like Torch are made for that, made for doing that efficiently, really efficient. Okay, so anyway, what do I need to do? I'm gonna take, I'm gonna make it into a Tensor in Torch first. So I'm gonna do img, sorry, equal. I'm gonna take Torch, the library, and I'm gonna say from NumPy, from NumPy, all right, and I take as input what? The image R. So what does that imply? It implies that image IO reads an image, gives you a NumPy. It's very standard, very common approach. And then from the NumPy, you just convert it to the Tensor so that it can run in Torch. So now let's go ahead and take in as input image R. So that should do it. Except that we want to be, you know, we want to also, because it's Torch, right? We want to get the dimensions as Torch wants them. Torch expects them to be. So we're going to take the image, which is now a Tensor Torch, and because it's a Tensor Torch, we can then call the built-in function permute. So this is what's so incredibly powerful about Torch, is that it, you know, once something is a Tensor Torch, you have all these functions for manipulating your tensors. Okay, so in this case, it's pretty simple. You know, 0, 1, 2 would mean basically the way the image is currently, right? So it would be height, width, channel. Okay, height, width, channel. But we want not height, width, channel, but channel, height, width, correct? So all we have to do is move that to here so that it is now channel, height, width. Does this make sense? Whenever you're doing these things, my suggestion is always do like a little test. Like, you know, do the, you know, call these sanity checks or whatever you want to call them. Check, you know, double check. But this does it for you. So now that we've done that, let's print out the shape, right? So I'm going to do print, and I'm going to do out, all right? And all right, so I'm going to run it again. And what do you guys think? What do you guys think? It gets difficult, right? And there's only one here. It's only one image. It's a color image, right? Height and width are the grid, height and width. Notice it shows these little dots, so it's not showing all the rows, it's not showing all the columns. Notice that it's got this one, that's RGB, right? So red, green, blue. You see that? And then for each one, it's got the height for just the one image. Now keep in mind, we have to do also the batch, because we're, you know, to be efficient with a GPU, you're not just going to feed it one image at a time, you're going to feed it 64 images at a time. All right, a better way of doing is showing the shape, right? So instead of showing this one, I'm going to go back to the script, right? And I'm going to try to do just like I did before, out.shape. Let's take a look. Oops, sorry. What do you guys notice now? If you notice, the original image was 976, 1334, 3. Now we have 3, 976, 1334. This is how Torch likes it, right? So that's what you have to provide, or what it expects, if you will. Any questions so far? Makes sense, right? Pretty easy. All right, so now we looked at one image. Let's now look at reading in. So that what we're going to do now is a little bit more complicated. Okay, we are going to read in 3 images, but the code that we're writing here could work for 100,000 images. Okay, so if you guys, so here, for instance, would be a good time if you want to practice, get the MNIST data set, right? The actual images in MNIST, which MNIST is the handwritten digits data set. Just keep in mind that's going to be in black and white. And so you could try to read that whole thing. All right. But what we're going to do now is we're going to read the 3 cat images and then basically create a tensor for them. Just one tensor is going to hold all of these. And this is how it's going to be, right? So remember that whenever you do anything in machine learning now, you're going to have to load all of your data into tensors. So let's take an easy example that we can kind of imagine and visualize. So we know that the images of cats are in the data folder, right? So let's go ahead then and go back to the script over here. Okay, let's create a new line for this one. Create a new line. So you may sometimes, so I've been saying the word batch quite a bit. Batch, what is this? You might ask, what is this batch that you keep talking about? Okay, so the word batch just means a group of things. So here's the thing. Let's say you have 2 million images, right? You have 2 million images. You can't really load 2 million images into the GPU at once, right? It wouldn't be that efficient because you're dealing with RAM and other things in the computer, right? So what you do is you take out of that 2 million images, little groups of images, right? Like a shovel, if you will, and you scoop some, and that basically is called a batch. It's a batch of things, okay? So that's what we're going to do. So here, for instance, I'm going to define batch size, the batch size, and it's going to be equal to 3. All right, so batch size equal to 3. And then now I'm going to create a actual batch. All right, just a sort of a placeholder right now where we're going to store our data. Okay, so the batch is going to be a torch tensor. It's going to be a torch tensor, let's say of zeros for now, but we're going to fill it in with data. Okay, so it's just being initialized. So then what do we need to specify? We will need to specify the dimensions and the data type that we want to use. So the data type is going to be, and this is kind of the torch approach, batch size first. All right, batch size first, followed by channels. How many channels? How many channels for color images of cats? 3, right? 3. And then the images of the cats are, I already know, they're 256 by 256. So that's the kind of thing you have to check. Also, very importantly, if you're not aware of this in machine learning, like in this example that I'm doing, you want to make sure all the images have the same size. Okay, so it doesn't magically, like you can't just grab a whole bunch of pictures that you have or images that you got off the internet, put them in a folder, and expect Torch to just magically deal with it, right? A lot of what you have to do sometimes is just deal with these dimensions. And you have to do, that's called pre-processing. Excuse me. All right, so then I'm going to do the dimensions. So it's 256, 256. And then the data type is going to be what? It's going to be unsigned integer of size 8. So we're going to say torch, and you can define different dimensions. It's going to depend on what you're doing. So uint, these are just kind of examples to show you everything that's out there. Do you see that? So this is a tensor of 4 dimensions. Batch size, which is 3, by RGB, which is 3, by 256, which is the height, plus 256, which is the width. Okay. So we've defined the tensor. It is currently an empty tensor, and we're going to feed in data into it. Okay. The next thing I'm going to do is I'm going to take, obviously, the directory where things are located. All right, data directory here. So we know where it's located. It's in folder data. And in there, I have image, and I think it's called image cats, if I'm not mistaken. Okay, so that's my folder over there. Make sure you get the paths correct and everything. Then after that, this next line has nothing to do with Torch. This is just a Python line. It's a list comprehension, as you probably have heard. And it's just to deal with getting files from a directory. All right, so we're going to create the list comprehension over here for name. Oops, sorry. For name in os.list directory. What's the directory? It's data _ dir, like that. Right, and I'm going to do, the list is going to be named. Okay, so this list comprehension will give us, it will result in something, right? So let's take a look at running this one. So I'm just going to print out file names. I'm just going to print out file names like that. Oops. And you can see I've got my my files. Now I printed out the file name, so now I'm going to go into. Let's go back to the script. So I need to grab those 3. So let's scroll down. And what do I need now? I need some kind of a for loop to read them in. Okay, so I'm going to do file name. So for I, comma, file name in enumerate. Remember that when you use enumerate for a list, it gives you like an index of the element plus the actual value in the list. So if it's the first one, it's 0 and the value. If it's the next one, it's 1 and the value, and so on. All right, so I'm going to do here then file names, of course. See questions? All right, and so now 1, 2, 3, 4. I'm just going to do a print of what I'm getting. So it's going to be, I need to do an os path dot join, which should join the directory and the file name so that we can read it directly. So I'm going to do data _ dir and file name. All right, let's just see what happens here. So I'm going to do Control X, Y. Let's scroll down. Oh. All right, let's try this one more time. There you go. So I'm able to print out all the files in there, right? Get all the files. And then what do I need to do now? I'm going to read them in, right? And load them into my tensor, batch tensor. So as you can see, once we are done with this, we would have a batch of data that we could actually use for training a model. Okay, training a model, for instance. So but let's just focus on this part first. So let's scroll down. So now instead of a print, obviously, what I want really is to do what? To use that to read, right? So to read the current image. So we could do, now we could take that image array that we had initially, image R, and we can say image R is image IO. Sorry. It's image IO dot IM read. So we're going to, with the library image IO dot image read, we're going to read in, try to read in the file. So let's try to do that. Let's see if it errors out. Okay, no errors, right? That tells me that there was no error. That's good. Good sign. So now that I have this one, 1, 2, 3, 4. Okay, and but remember that these things that I'm reading are currently what? They're Numpy arrays. I need to convert them to Torch tensors. And so I'm going to do img underscore t just to kind of be more consistent. And then here I'm going to say torch. So torch dot from numpy, and we take img array, right? So we take img array, we read it in here. So that's going to give us the tensor. Then what's the next step? Remember that this is currently height width channel. We need it to be channel height width. So then I'm going to proceed and do image t image underscore t dot permute, just like we did before, 2, 0, 1. That just moves the channel to the beginning, right? Now these images are PNGs. All right, these, I think we saw that. They printed out, they had a PNG extension. PNGs have transparencies. It's basically like there's an R, G, and a B, and then there's an additional layer called a transparency, etc. So a good way is always to print out the dimensions, just to look. But once you determine that, what you can do is just slice out the transparency. So what we can do is we just take the img underscore t and do something like that. Do you see that? So that way we just retain the red, green, and blue. Okay, and then finally, since we have a batch that is 3 by 3 by 256 by 256, now we have to take each of those images and assign them to the batch, batch 0, batch 1, batch 2, right? That's where the enumerate comes in handy, because it's, we've got the index there. And so here I can just say batch, I can say batch I, and to batch I, what do I assign? Image underscore t, right? The current image that I just grabbed. All right, and then once I've done that, we want to go ahead and print out batch. So print batch dot shape. You guys see that? We can also, I'll do this last, and then print batch itself. All right, so let's proceed. See the dimensions? So these are the things that you'll have to do. 3 by 3 by 256 by 256. I've got it there. You see here, you've got one image, the first in the batch, with its own RGB and its own 256 by 256. Then I've got the next, oops, not too fast. And then I got the next image with its RGB, and then each one, it's 256 by 256, and then the final one, and so on. Does this make sense? Yeah, all right, good. So that's, as I said, that's reading the images. So today the focus will be on reading this. So let's go ahead and, what time is it? It's 3:19. So let's take a 10-minute break here. All right, and then we will come back at 3:29 and just finish up the rest. I'll stop the video at this time. Hopefully it recorded. Just hit end, I think.